Bom dia, pessoal. Bom dia. Thank you, guys. So probably those were my only Portuguese words because we were lucky enough to have a very international event with a lot of international people around here. Anyway, I would like to welcome you to the first edition of JNation. It's a real pleasure to have you all here, and it's also a pleasure to be your host for today. So let's start to have all the important stuff first. So if you guys haven't noticed yet, this is Wi-Fi. There is no password, so try to break the Wi-Fi. We hope that you're not able to make it, but we did pray to the conference gods to see if the Wi-Fi will hold, and we hope that it will. Anyway, we're sold out, so it was a real pleasure for us to have this happen, and it really surpassed all expectations because we were not waiting for this to happen. We had no idea when we start this conference that we'll get all these people. So thank you so much for that. Anyway, a couple of things that I would like to show you is we actually have 450 attendees, probably 10 more because we have like a couple of last signups. And we've seen some Java code over here, and the reason why I added over that is if you've seen some of my work, most of my presentations, I do live coding and I show some code. And this was the first presentation I was doing without any code. So I thought that I'm going to add some code over there because I don't want to have a presentation without code. So we have 450 attendees. We're really sorry for the people that were not able to make it. So hopefully we'll increase the venue next year. If you'll see, you only see this part of the venue, but later we're going to go to the other part. So the venue is quite large. We're able to hold a lot of people, but we wanted to keep things simple, so we kept for this. It's been some exciting times for Java, right? Java 10 just came out a couple of months ago. Who's excited to have Java 10 be like JavaScript? No? Who's using Java 10? Yes, a couple of people over there. Steve, of course. And Java 9? No modules. One person. Java 8? Okay, nice. Java 7? Oh, guys, you have to upgrade. Java 5? No? Java 4? Okay, that's not that bad. So at least we're on Java 7, which it's okay, but please guys upgrade to Java 8 at least. But try to go with Java 9 or 10. Anyway, a couple of other things have been happening on the Java world. So we now have a much higher release cadence with a couple of new features coming up every 6 months. We have a couple of awesome Java languages coming around. Kotlin is one of them. It's being a really popular language. And of course, we cannot forget about all the Jakarta initiative, which open sourced all the Java stuff to the Eclipse Foundation. I'm going to have a session about that as well later in the afternoon. So I think that interesting that we see all the Java community coming together and making all these great things over the last couple of years. So for me, it's really exciting technology to be working on, and I'm guessing that that's why we sold out the event, because you guys are also excited about working with this technology, and you want to be around all the greatest experts and learn all this stuff. So one of the things I also would like to tell you is how all this JNation thing started. And for that, let me allow you to tell a little bit of my personal story. So I guess that, I don't remember exactly the year, I think it was 2012, I went to my first Java 1 conference. Who knows about Java 1? Who has been in Java 1? Not that many. You should go there. Now actually it's called Oracle Code 1. And for me, I was a newbie, I didn't know the community, but I was well received by all the great people that are there, and some of them really encouraged me to start a community, here in Coimbra. At that time, we did have a jug, which was the PT jug, but we didn't have one in Coimbra. And usually, like PT jug has all the meetings in Lisbon, so it was like hard for me to go. And then for that particular reason, I did found the Coimbra jug. So if you want to have like a conference like this, you cannot just go, okay, I've been in my first Java 1, I come to Coimbra and say, no, I'm just going to do a conference. No, you have to build a community first. So the Coimbra jug was like an excellent occasion for us to start building a community and start having a couple of sessions so people get interested in it, people see what we were doing, learn with each other, connect with each other, learn about it. So who's here is on Coimbra jug? Yes, maybe 40% of the room. I know that a lot of you guys are actually from Lisbon and Porto, you're not from here. But the interesting thing is, after I did found Coimbra jug, a couple of other jugs also came together, like the Porto jug and the Beira jug, and also the PT jug. So I would like to see more jugs in Portugal working more with the local cities, so we can build those communities and then build these huge events so we can share even more and connect even more. So we see a couple of pictures of our old events. So we do have over 400 members, which is awesome for a city like this. Not only from Coimbra, I know we have a couple of people from other cities, especially in the center, like Leiria, Aveiro, Amigável, Cantanhede, also a couple of people from Porto and Lisbon. And over these years, oops, sorry about that. And over these years, we built a community and we have a couple of events which usually are free of charge. So you can go in, you can connect with people, you can have people go around. And now I think we have a terrific job on these events that some of the people you actually see here, they got involved and they're now part of the organization that brought this event to you. So I'm really happy that we're able to do this as a community. Still, we did want to do something here in Coimbra. And for that reason, we did partner with an association that was recently found called Alpha Coimbra. And Alpha Coimbra is an association that wants to energize the city, wants to make events on the city. So we did partner with them because basically we have the same goal in mind. We wanted to make an event over here. They also want to make a couple of events. And we want to basically make Coimbra a great city where we can hold those events. I'm not sure we have any time to visit the city, but we do love our city and we want to make it strive and grow and energize it so we can have all these events. And I really think we are in a great position because we're in the middle of the country, so it's closer for Porto and Lisbon to come over here. Anyway, we have prepared a video for you, so we hope that you enjoy it. It talks a little bit about Coimbra. So. And yeah, so we did partner with this association. The Coimbra Jug and the Alpha Coimbra came together to work on this event. So I would like to introduce you to our team. All of these people have been working really hard to make this great event for you. So they'll be running around the entire conference, and if you happen to find them, please hug them, because they did a great job just for you guys to be here. So thank you so much for them. Now, I want to tell you a little bit about the conference. So, as I told you, we have like 450 attendees. We have 2 session tracks. We have 30 volunteers almost. We have 15 speakers, or 14 without myself, or 14 sessions. And we have a huge amount of sponsors that we didn't have any idea that we're going to have. So it was a real surprise for us to have that many sponsors. Let me share like a quick story for you. So this conference was supposed to only be for 200 people and a single track. And the interesting thing was, when we started to organize the conference, we quickly sold out those 200 tickets. We quickly have a lot of sponsors wanted to come in. And I think that really shows on how Java is really important for the companies that are involved, and also for the people that actually want to learn about it. And unfortunately, we did have almost 100 people on the waiting list to get in. And even though we wanted to have them, and we did have room to have them, we didn't want to go overboard. So hopefully next year we'll be able to make a bigger event so we can hold way more people. So another information I want to share to you is a couple of information about our budget. So as you have noticed, the ticket price for the conference is really, really low. One of the fundamentals of this conference is we want to make a community conference. We want to make accessible to any developer, and to make this accessible to any student. So the entry barrier, the ticket price is super low. If you see, our ticket income is only 22% of all our budget, and the rest of the budget is actually coming from sponsors, 78%. So without them, this will not be possible. So I really like to really thanks about to Critical Software and to Self-Focus, because they are our platinum sponsors, and they also sent a lot of developers over here. So thank you so much for that. Critical Software is a local company based in Coimbra, so it was natural for them to support our event, and they did support our Coimbra Jug in other occasions in the past. Self-Focus is actually a Lisbon company that came to Coimbra to support us. So it was also a pleasure for us to have you here, even though we are in a different city. So thank you so much for all the support. We did have a lot of other sponsors, so we do have an exhibition floor on the top. Some of them have some stands. Please go over there and see what they have to offer. I know they have like some cool demos for you guys. Again, these will not be possible without the sponsors, so please, if you want to keep having this event affordable, we do need to take good care of them. So have a look and thank them very much. We do have a few things for you to enjoy as well. If you notice your bag, there is like a small card. This is for a game. So if you go to your bag, take out that card, you can go to each sponsor stand and they will give you a sticker. You can place that sticker on your album, and when you have that complete, we'll have a reward for you. The rewards are limited, so you're able to get a Raspberry Pi Zero that we're going to give to the first few people that complete the album. And in the end, you'll still be entitled to win a PlayStation 4. So this is like a way for us to thank the sponsors as well, and to make you have fun in the conference. So try it out if you're interested in that. Just go to the stand, have that, and we'll be happy to give you a reward, and you'll get entitled to get the PlayStation 4 in the end. One of our sponsors is actually having an interesting initiative. So Operação Nariz Vermelho is a association, a non-profit association, and they do try to bring happiness to childs that are in hospitals by bringing clowns that act as doctors and try to make some joy on their day. So they're gonna try to collect some donations, and they're gonna have a raffle as well. So please support us, and we will be happy to also support these initiatives, because I mean, we are all here. We're like a community, but I think we also need to support these kinds of other initiatives, because everything is not only about technology. A lot of things about human beings, and if we can make a couple of people happy, then I think we have done great. So this will also be possible without our speakers. So I would like to really thank everyone that came in. I know that a few of our speakers have had a rough time to get here to Portugal, but we're really grateful that you came. Thank you so much. This won't be possible without you as well. They do have great sessions for you. Please go to the sessions that you like. You do have, if you haven't noticed, you have the schedule and the program on the back of your badge. So they have some interesting topics. Have a look on what they have to say, and also hug them if you see them, because I mean they made such a huge mileage just to get here, because as you know, we don't have an airport, so it's sometimes difficult to get to Coimbra. But yeah, I mean, I have really to thank them for them to take the time and actually travel over here. So another thing that we're going to have, all the sessions are going to be recorded, and we're going to put them on YouTube. As we speak, these sessions being live streamed into YouTube as well. And all the other sessions are going to be live streamed as well. So if you happen to go to a session which is full, you can always go and watch it live stream. Or if you want a session and you want to catch up other things later, you can always replay it back at home at your own convenience. One of the things that we have is we do have 2 rooms for 2 tracks. So if you really want to go to a session, go early. So you make sure you can get a spot. If you don't get a spot, don't get frustrated. Just go to the other session, and then you can catch up later on the YouTube, the session that you want to go. A piece of advice, most of the times, or the usual times when I learn the most, is when I go to sessions that I don't really, I'm not really into. So what I want to say is, usually we do have our own taste. We like certain types of technology, but usually when you go to sessions that you don't feel comfortable about, that's when you learn the most. So don't just go out if you don't find a spot in your session. Go to the other session and maybe try to learn something about it. We're also going to stream these to the Virtual Jug community. Who knows about the Virtual Jug? Yes, maybe 40% of the room. So if you are not on the Virtual Jug, please sign up. It's completely free. At the moment, this is an online community with over 15K members. And if you know the Virtual Jug, you know that I'm part of it as well. I'm not sure, I don't think we have our founder, because he should be here. Simon, are you here? No, he's at the hotel. But yes, Simon Maple did start this online community, and he made a terrific job on growing it to the numbers that we have right now. And basically, it's just a replacement when you don't want to go out of your place, or you're far from the local Jug meetings. You can go to the Virtual Jug and you can see on the Hangout or on YouTube, you can see a session going on over there. So we're also going to live stream to the Virtual Jug community. So we hope that some of you guys are watching it right now. Finally, food. So also on your badge, there are some coffee breaks and some lunchtime. So those are going to be held in the 1 floor. Feel free to grab wherever you want. We also have a couple of surprises. There are a couple of sweets available during the day. And there's also coffee, which basically everyone needs coffee, right? Yes? Yeah. There is also coffee available for you the entire day. So hopefully we'll get you fees and coffee, and we get you coffee for you guys, so you can keep up with all the sessions going on. Finally, we do have a party in the end, so that's also going to be held in the first floor. This is going to happen after the final keynote. So we're going to have a couple of beers and a couple of snacks as well. I know some of you have traveled from a long place, like either Lisbon and Porto, and you might have to leave early. But if you want to just go over there and drink a couple of beers, we're going to have some of the local brewery over here serve us some really tasty beer. So if you like some beer and you want to go do some tasting, go over there, and we have a couple of music and stuff going on. So just go over there, drink a couple of beers, and then you can go home. And finally, please enjoy the conference. Oops, sorry. Yeah. So please enjoy the conference. We did work hard to make a great event for you. Okay, this is not working very well, okay. We did work hard to have a very great event for you. We have a lot of people over here, so please be respectful to each other. If you find the people with the red shirts, they should be able to help you with any problem that you might have. So have a great event. Thank you so much for joining. And I'm going to hand the stage to Steve that traveled along to come here with you guys.
So before I let Roberto escape here, he's done an awesome job here with the community in Portugal, and I think he deserves both a hug, but also a big round of applause. So, great job.
Thank you, Steve. It was also, so a couple of words as well. It was also because of Steve we were here as well, because it was one of the people that inspired me to start the community. He runs Oracle Code 1, Java 1, so, and that's a 5 days conference with like, I don't know, 5K people. So you can imagine how much more these guys have. So thank you so much.
No, thank you.
Yeah.
And last time I was here in Lisbon, actually, well,
yeah,
I was here in Portugal.
Yeah.
I was driving my motorcycle and I came to speak. And I thought it would be appropriate to show you guys a video of my most recent adventure in Japan. So here's that.
I've been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services, which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle. So it's a very efficient way to hit up a bunch of different communities throughout Japan. In the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and the user groups, and there's large user group communities. But they don't always get the attention and the visibility which they would get normally if they were in a large hub like Tokyo. On this tour, we have Sebastian Daschner, who is a Java champion from Germany. He's presenting about cloud-native Java development. We have Kurt Pepperdine, who is a internationally known performance tuning guru. And lastly, we have David Delvasse, who is a Java EE and WebLogic evangelist for Oracle. It's great that we share a common interest in motorcycling, and we're able to use that to spread a little bit of our passion about Java to the global user group.
Okay, so thanks for being part of the global Java community by coming to this conference. So what I'm going to do this morning is I'm going to talk a little bit about different technology hype that you guys probably have heard about, either from different magazines, different blogs and articles, or even some of the sessions here in the conference today. So we're actually going to give some of the speakers here a chance to redeem themselves, because I'm going to actually talk about some of their topics. And I'll give you guys just enough information, and we'll see if they can add something to it to prove why you should come to their session. So we're going to cover 5 different technology trends this morning. So we'll talk a little bit about blockchain technology. So we'll get into a little bit about digital currency, but more about the underpinnings for how the technology works and how you can apply it to different industries. Chatbots, which is a lot of fun. How many folks actually have a chatbot, like Alexa, Google Home, or what's the third one? Apple has their HomePod at home. How many folks have a chatbot? Okay, excellent. So quite a lot of people here are already advanced chatbot users. My daughter uses her chatbot, and she actually uses it as an alarm clock. So you think that is not a very advanced usage, but the school schedules she has to keep track of actually require a more advanced alarm clock than something you just put a time on. Serverless computing also is a big craze. We have many serverless sessions here today. Actually, I see some of our speakers here, so I'll bug you guys later. DevOps as well. So how many folks are using either like an agile methodology or DevOps in your day job? Okay, quite a few hands. So a lot of folks here already know about this, but I'll cover that a little bit. And then machine learning and AI. So I think this is the futuristic topic. You know, all of us are wondering when the singularity is going to come. So I'll let you know. All right, so just to start out with, I think this is the most trending topic of all these. As Roberto mentioned, I'm on the program committee for a bunch of conferences, including Oracle Code One, formerly Java One, and we get a lot of submissions around technologies like blockchain. And the question is, why blockchain? Why is this an interesting technology? And I think really it has a lot of consumer interest because of Bitcoin. So because there's a digital currency which has been trending in the news, been getting a lot of attention and visibility, this is something which everybody believes they know a little bit about, and possibly even are investors in Bitcoin. So here's the Bitcoin value, and as you can see, it went crazy earlier this year. So it shot up to over $20,000 for a single Bitcoin. Does anyone here in the audience own some Bitcoin? Okay, so now you're brave. Everyone was watching. They're going to come after you afterwards for free drinks. So even though the price of Bitcoin has dropped, it's still, a single Bitcoin's worth about $10,000. And it's, just because you have Bitcoin doesn't mean you have this large quantity. It's a currency which can be subdivided, so you can have very small increments of Bitcoin. But you can see that the growth of it has been exponential. So I did some Bitcoin mining really early on just to try it out, maybe around 2015, 2016. I thought the whole digital currency was a crazy idea because how could you have something which is backed by nothing and have it have a real value? So I sold all my Bitcoins at a really cheap value. Not a wise financial decision, apparently. One of the other attributes of the Bitcoin network, and this is currently a problem with Bitcoin, is the amount of energy consumption which Bitcoin takes. So because the value's gone up, it's now more lucrative to do mining. So obviously, if the value of Bitcoin goes up, you want to get Bitcoins, and you're willing to spend more resources and money to mine Bitcoins. Mining Bitcoin serves two purposes. One is, it's a way where you can actually get Bitcoins, which is at a decreasing scale over the lifetime of the currency. But the other one is it actually serves as the system which controls the distributed ledger for all the transactions. So it's a way of making sure that the system actually works. But the problem is there's an overabundance of Bitcoin mining, which is consuming a huge amount of energy. Basically, because of the way Bitcoin's set up, your amount of energy usage is proportional to the value of Bitcoin. So Bitcoin is currently using the equivalent of 6 million households in the US, which is crazy. Ethereum, which is the second most popular cryptocurrency, is consuming about the equivalent of 1.8 million households. And I think an easier way of looking at this is basically Bitcoin uses the same power consumption as the entire Czech Republic. So it's quite a lot. So there's different technological ways to solve this. So both Bitcoin and Ethereum are looking at different patches to roll out where they can change how the currency works to reduce the consumption. But it is kind of fundamentally a challenge with these sort of systems, and it gets into other technological challenges with using Bitcoin for things which might be interesting for us. But before that, let's talk about how Bitcoin works at a high level. So it's really kind of ingenious, but the core of it is blockchain, which is actually the technology which we care about as geeks. And this is the distributed ledger. So this gives you a kind of distributed public ledger, which is cryptographically secure and has all of the different transactions in it. So this is an example here where the chain continually grows. For each of the blocks which you add to it, you hash the previous block, and then you also hash in values from transactions which you're adding to the distributed ledger. And then there's a timestamp and a nonce. And the nonce comes from the mining process, so that's kind of your secure key. And then by the way which this works practically for Bitcoin purposes is it's basically all of the Bitcoin servers are competing to calculate this, and then it's the basically consensus or majority on the network which would agree that this transaction is the right next one in the series. So you can have cases where there's multiple different blockchains, and then the blockchains which don't win get discarded, and the blockchain which does win becomes the new blockchain. So this is all designed around having a very large pool of machines which are holding the distributed ledger state, so you can have a cryptocurrency where it's very hard for somebody to circumvent or cheat the system. So it's an interesting application, but this core technology, blockchain, also has other applications which you can use for solving different technological problems. And so on the left side here is a little bit about public blockchain and some of the limitations of it. On the right chain is private blockchain. So private blockchain would be, for example, if you set up your own server, your own infrastructure, running a blockchain network, and then you had a collection of different companies which were transacting in the blockchain. A lot of cloud providers as well also provide blockchain implementations now. So some of the limitations of blockchain as a public system is, in general, it's based upon a peer network, reconciliation by the majority, as I mentioned, but it has really long transaction times. So when you use a Bitcoin, you only get 7 transactions per second, and each transaction can take up to 10 minutes to complete. So if you're building an enterprise system, then that would be a big limitation to have like bank transactions or things which were delayed by that much. Ethereum is quite a bit faster, so 15 seconds for completing a transaction, but still much slower than if you're going against a standard database. You're also limited with the size of the transaction. So in the case of Bitcoin, they limit the block size to 1 megabyte. Ethereum, they limit their gas size to, what was that, 7 million gas, 8 million, about 8 million gas. So it's different ways of limiting the system, but basically in a public system, since the distributed ledger is shared by everyone, you want to make sure that it's not too large, that any of the individual nodes can't hold on to the whole ledger. So I think the current Bitcoin ledger is up to something like 30 gigabytes, and it's continually growing because it's a history of all the transactions. The last limitation is smart contracts. So one of the other things you could do with Bitcoin is you can have the mining nodes or the participating distributed nodes execute different logic and then have smart contracts where there's actually code executed as part of the contract. This isn't possible with Bitcoin. It is possible with Ethereum, and then it's limited by the gas. So basically you have some limited calculation time, and then if you exceed that, then your transaction doesn't go through. And obviously, you have no privacy on this side. With a private Bitcoin implementation, you get rid of a lot of these limitations. So you can have your own network rules about how you invite people to the network. You can choose different forms of reconciliation. So a common one for this case would be doing a consensus reconciliation, so all the nodes have to agree that the transaction's valid. You can have much shorter transaction times because you have a smaller pool of nodes participating, and then different implementations which are tailored for this use case. Much larger data in the transaction. A very common use case for this is smart contracts, which I'll talk about a little bit, and then obviously it can be a private Bitcoin network as well, or blockchain network. And then there's some common implementations of blockchain. So I'd say the one which is probably most talked about, and this is the one which most of the cloud providers have implementations of, is Hyperledger. So Hyperledger is very configurable. You basically plug in your own helpers to figure out how consensus works and how it does different reconciliation. You can also do smart contracts in your choice of Go or Java as languages. And you can do cryptocurrency with this as well, using chain code. So it's a fairly flexible architecture for doing blockchain. R3 Corda is another blockchain implementation, and this is really more focused at financial services. So this has a lot of focus around smart contracts, which can be written in Java or Kotlin. You can also choose different consensus. So in this case, you can do transaction level, or you can do what they call notary nodes. So you can see, again, it has a lot of pinnings to the financial industry. It doesn't support any sort of cryptocurrency. It's really just designed pretty much for smart contracts as the use case. And then the last one is Ethereum has a private implementation as well, and you can use this for consensus with like mining proof of work ledger level, and it gives smart contracts in their own proprietary language called Solidity. And of course they have a cryptocurrency as well because it's based on a cryptocurrency. So these are different implementation choices you can pick based on what you want to use for blockchain. But the most common use cases, pretty much all the use cases are on this slide. So blockchain is really focused on a few industries. So financial services is one industry where it's, I think, becoming common. So using financial ledgers, trading, payment processing, global transactions. There was a good use case, I think it was some banks. They have a system where they have transactions going between banks. So one bank will lend money to another bank, And then they're using a blockchain to keep track of that records because they have their own independent system. So it was a good way to keep a distributed ledger between a consortium of different banks. Another industry which it's really good for is legal. So the smart contracts apply well to legal if you need to define rules, have automated actions, automated expiration dates. Also, it has really good tracking since it's a distributed ledger, and you can restrict access to different parties. Medical and healthcare, you can use it to secure patient information, medical claims. And then IoT, theoretically, it's a platform where you could have a bunch of devices interacting on a network, doing inter-device communication, storing data in the blockchain. I'm not sure anyone's actually done the final use case. So how many folks work in one of these industries or think they have a use case for blockchain? Okay, so a couple hands. All right, good. So you guys should pay attention. Everyone else in the room should just use a database. Realistically, blockchain's too complicated, and whenever there's new hype, people like to overuse it. So it's one of those things. I think it's a really interesting technology. It's like cryptography. Like it's something fun to dig into, learn how it works. Maybe do some prototypes, like learn and maybe even give a presentation to the local user group. But practically speaking, it's probably not something which makes sense to implement unless you have one of the specialized use cases. Basically, you need a use case where you need a distributed ledger, you have a bunch of untrusted parties working with each other, and you can take advantage of some of the features like smart contracts or something. But if you're not in that specific use case, then a good old database is pretty good. And basically, the goal of this presentation is to give you guys just enough information so you can evaluate and figure out which things apply to you and you need to learn more about, and which things don't. And then when you're hanging out at the water cooler, you can talk credibly with your colleagues who get way too excited about different technology trends, such as chatbots. So chatbots, actually, I think is one of the more practical ones on the list. I mean, we all have chatbots in our house somewhere. Quite a few folks raised their hand and said they have at least one of these devices. Even if you don't have one of these devices in your home, probably your phone has either Google Assistant or Siri or some sort of chatbot integrated into it. And even if that doesn't apply, where you don't like talking to your phone, which I usually don't, except when I'm on my motorcycle, you probably text using communicators like Facebook or WhatsApp or different communicators, and a lot of companies are integrating chatbots with those. So this is all very practical stuff. So just to give an example of this, how about a reverse chatbot? So you guys are used to talking to a chatbot, but what about the other direction? So this is a short clip from the recent Google Next conference, or Google I/O, I think.
So how can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Mm-hmm.
So the one on the left is the chatbot, the one on the right is the person.
At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's your first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day. Bye.
Okay, so a little creepy, maybe. You notice that they put little pauses, little expressions in there where it's actually very hard to tell the person from the chatbot. So they later commented after the presentation, and when they release this over the summer, they are going to have the program let the person they're calling know that it's a robot. Right, so impersonating a robot over the phone is not, very ethical. But it's interesting technology, and it has some practical implementations. So, what Google's using this for is they can actually do things like check non-standard store times, They can call stores for basic information for their catalog, and they can provide this as a service to you as an end user if you want to book an appointment like a haircut or a restaurant or something like that. And I think this shows that as technology evolves, as our both speech recognition and the ability to synthesize realistic speech improves, chatbots are going to become more and more a part of our life. I gave this presentation, actually I wrote this presentation on the road in Japan. So each city I stopped at, I added an additional section of this presentation, and we stopped at Kumamoto, and I was talking about chatbots, and the guys there made me put Line up here. One of the local companies was actually doing an implementation with Line for their chatbots, which is a very popular communicator in Asia. So if you use any of these, or if you have like a work purpose where you could integrate with these, this would be a place where you could apply some technology knowledge, create an additional API for your application, and take advantage of chatbots which already exist. So, of course, I work for Oracle, and this is a view of the Oracle Cloud. This is one of the demos which we give at the Oracle Code conferences, and it showcases how you can build a chatbot, basically using a platform as a service to do a simple user interface, set up some rules, some pattern recognition matching, and then set up a chatbot which will respond to a car order. So in this case, it's buying or selling a car, and it's fairly straightforward to set up. You have a bunch of different possible methods which will get called. So in this case, it's buy car, sell car, or greeting. Each of them has different rules and pattern recognition, which will match against the speech or the text coming over the messenger. And then based on how close the match is, it will have a confidence level and try to pick one of these as an appropriate response back to the user. So this is stuff that you can apply some of your knowledge and then actually turn this into something which you can add to an existing application. Okay, so the next topic I want to hit up is serverless. This is a fairly recent trend, but I'm just curious in the room if anybody actually is using serverless in their company today. All right, so I think, I saw one hand in the back. Okay, I was going to say, Roberto, I think we got our first negative poll. So not many folks are using serverless yet, but I think it's a really interesting technology. Clearly, you can see from the conference talks today, I think we have at least 3 or 4 talks on serverless today. It'll probably get mentioned in the closing keynote as well, because that's on cloud native. So this is all stuff which folks are very excited about. But let's break it down and figure out exactly what is serverless and why we might care about it. So with traditional computing, you purchase your servers up front. You have a monolithic architecture, or maybe a microservice architecture if you're a little bit more modern. You scale by permissioning new servers, and basically it's each of the servers in a certain location. So you have to get servers that are geographically distributed if you want to do a global deployment. With serverless, some of the advantages you get are you're basically paying for what you use. So you just pay for the server time for your functions as they run. You're actually building smaller functions because they just spin up when requests come in that you would even in a microservice architecture. And then you're leaving the scaling up to the cloud. So the cloud is going to scale up when you need additional load from more users. The cloud is also going to take care of latency, so it's going to spin up instances that are relatively geographically close to the users based on the data center distribution. So a lot of the ops side of this problem is solved for you in the serverless side of things. And in an ideal world, this is what you want to get out of serverless, right? So here on the x-axis we have scale, on the y-axis we have cost, and in a traditional server environment, you pay for a server, and then you have a while before you're fully utilizing it. So you have unused server bandwidth, which is both extra money and then extra resources. It's an extra machine running and consuming resources. In the serverless case, you're sharing kind of a multi-tenant pool of serverless instances. They're only processing your requests when you get requests coming in. So if you have requests which are not constants, kind of like different peaks and loads, or if you are scaling up gradually, you don't have to think about buying more servers and building out your infrastructure. So this kind of simplifies the whole ops side of doing a large-scale deployment. So it looks good, right? So I think we got more people who might want to do serverless. Unfortunately, this is what it actually looks like from a graph perspective. I kind of cheated on the previous one. So I work for a cloud provider. We all do this. We mark up things. So the price you pay for a server is not the price you pay for serverless. There's various different pricing models, but there's some price you pay for individual transactions. There's some price you pay for milliseconds overage. Usually there's like an API gateway or something you have to actually get REST calls in, data and storage costs. But your average cost is cheaper at the low end. So when you have few transactions coming in, or when you're scaling out an application, it works really well. Once you hit massive scale, you're probably going to pay more for an architecture like this, just because of the way which it's built. So this is still you're getting benefits here, right? So you don't have to worry about scale. You don't have to worry about uneven loads, and you also theoretically should spend less on ops, right? Because you're just deploying code to a serverless environment. You don't actually need an operations team and all that stuff. And we'll talk about DevOps in a bit as well. So that's the reality. There are different platforms that you can build. So I have a few of these platforms here. So AWS Lambda. So this is kind of the first serverless platform which was available, very popular. Integrates well with the entire Amazon stack. I guess the main disadvantage here is it can only be run on Amazon infrastructure, and it's mostly proprietary. There's no open source code base you can look at to see the implementation. GCP Functions, or Google Cloud Functions, is also a serverless platform. They provide a nice little emulator so you can run it locally, which is cool. So you can run your serverless functions right on your desktop to test them and check them out without deploying it to the cloud environment. They do release the source code for the emulator, which is also cool. Although the production implementation is not as open. So you have to run it, basically you have to run it on the Google Cloud, and they have their own implementation running there, which is slightly different than the emulator. The last one, Azure Functions, is probably the most open on this list. So they did open source their entire stack. You can run it locally or in Docker images, but it's gradually coming out. So there's some features which are on the Azure side which aren't available if you're running it locally or you're running it outside of the Microsoft environment. So you're still somewhat tied to the Microsoft platform. So in general, this highlights one of the challenges with serverless is when you're picking things which are like new and innovative, and people are trying to differentiate on it, you sometimes suffer from vendor lock-in. So if you choose to architect your application around one of these implementations of serverless, you're basically tied to a single cloud provider. As a result, there's been a bunch of open source serverless frameworks which have been coming up, which are trying to fill this gap for folks who want to have a non-proprietary solution, but then still want to take advantage of serverless environment. So the first project is one which was originally from a company called Iron.io. We acquired it at Oracle, and it's called the FN project. So David Delbase actually has a talk about this later today. Oddly enough, we released and we have the open source framework available, so you can run it yourself on your cloud provider or local system of choice. But we actually don't have a commercial offering around it yet. So eventually we will, but it was nice that we actually got the open source code out there and you can run it. OpenWhisk is another one which is quite popular. So this is from Apache. I think IBM runs this on their infrastructure as an option if you want to deploy it to their cloud service, and it's entirely open. You can run it on your cloud of choice. OpenFast is another open source serverless offering, and so is Kubeless. So you have a bunch of different options, and these are just a few of them. There's quite a lot more folks who are building serverless platforms, so you can take advantage of any of those. And then I'll kind of propose an alternate model. So if you actually use one of those open source frameworks, you actually have choices. You can take advantage of the low cost option when you're scaling out to just run on a managed instance. And then as you scale up, if you find that you want to run your own infrastructure and invest in that, then you can actually get advantage of having your own servers running an open source stack. So I'm calling this own serverless, but I think this is a reasonable way to approach it if you want to look at it from a cost perspective purely. So, top 5 reasons why you might need serverless. So, number 1, your sysadmin quit last Friday. So, rewrite your app in serverless, then you don't need your sysadmin, you're done, right? All right, number 2, you got 1 million free queries and you have to use them up. So actually, a bunch of the cloud providers, I think Google gives 2 million, Amazon gives 1 million, Microsoft gives 1 million free queries. So when you sign up for their cloud services, you get a bunch of free queries, which is cool. Although the not cool part is actually it's a huge revenue generator as well for them, because if you actually get anywhere close to 1 million, you have really good scale, and you're going to use a lot more. So you're stuck on their platform, and you're going to be buying lots of cloud credits in the future. You're already doing microservices and want even more complexity. So this one might be controversial. I think microservices is getting really good adoption. I think it's really more a play on kind of team organization and orchestrating across different teams and companies. But it does introduce complexity, and then of course serverless architectures are a whole other can of worms. So doing large-scale applications with an entirely serverless architecture can be challenging. Okay, number 4, you have a short memory and like applications with minimal state. So in general, serverless architectures are stateless. I think, was it Microsoft or somebody's coming out with like stateful serverless type capabilities. But in general, the architecture is designed for stateless. So it's really designed so you can build applications. They spin up a serverless thing, it executes a query, it shuts down. And you have to design your whole architecture around that. So you're not gonna run anything which really needs to keep a lot of session state or activities on the back ends. And the last one, someone else is paying the bills, you just want to code. So this is my favorite one, because one of my habits as a developer historically is I would always hop on the latest trends because I just wanted to try it out. And sometimes when it wasn't a great technology trend, that was at the expense of my employer, but we built good software, it worked great, it was well architected, and I wasn't the one who paid the bills. All right, so I'm going to give my fellow speakers here a chance to rebuttal. So I would like to invite up Raphael, David, and Bruno to the stage. All right, come on up, guys. And can we get a mic? Here, we can just, well, why don't you guys come up here? It's easier for them to see you. Hey. Welcome.
Hello, everyone.
Hey, man. Good? Okay, so where's your mic? Where's our, we don't have mics. Where's our mic runner? Over here. All right, so I've been totally destroying your presentations, right? I'm up here in the keynote telling everyone why they don't need serverless. So you guys have to rebut. You guys have to like prove that there's a reason why the world needs this, and they should come to your session. All right, Bruno wants to start.
I think because you are from Oracle and David is from Oracle, let's start with David.
Okay, so one of the ideas with serverless is that, well, there are a bunch of servers. But as you said, at the end of the day, what we want to do is to write code. With serverless, basically, you will spend your day on writing business code, and that code will be deployed in infrastructure, but that infrastructure will be managed by someone else. So those servers, managing those servers and so on is someone else's concern.
Okay, so that's good. So we save on the infrastructure.
Yeah.
Okay. You guys convinced?
Yeah, let me get it. Well, one of the things that we like to try serverless, it's because we are developers and we like to do cool things, right?
So you're like the cat on the keyboard.
Yeah, we like, as Stephen said, we like to do cool things. We like to try. We like to learn new things, and of course, with serverless, since it's a new programming paradigm, a new deployment paradigm, so we like to learn And once we learn, we can take the decision with our work colleagues and say, is that the thing that we want to use from now on? And of course, there is also another reason, which is complement microservice architectures. For example, joining, like he said, making microservices more complex. But in fact, you can ask yourselves, do you want to build something or do you want to buy something that already exists, a service that already exists? If something already exists, maybe you can use functions to just implement a call to that existing function or make a glue between two different services. That's something cool, right?
Yeah, okay. So maybe like if you're already doing microservices, it's like the evolution, right? Yeah. Okay. All right, Bruno, you get the last word, man.
It's funny because we spoke on the phone, so I'll basically say what I told you before. Let's imagine you got a use case. You have to implement this little application. It's a web application or a mobile application. Somebody figured out how to do the interface. You're just a back-end developer. And the application needs to get some data from the database, whatever, MongoDB, Oracle, MySQL, Postgres, whatever database. Or process some data, convert some image, or whatever. And you have to implement this functionality on the back end as fast as you can. You don't want to spend time setting up servers. You don't want to spend time setting up, writing a Docker file, setting up Kubernetes, or all of that. You just need to implement that REST API as fast as you can. But you want to implement in a way that it is easy to move to an actual infrastructure, as Stephen said later, if you feel like the serverless platform it's getting more expensive than traditional infrastructure. So I think serverless is a nice approach for getting started. And remember when they built Twitter.com using Ruby on Rails? Because that was the easiest, fastest platform to create a startup-like application. Mm-hmm. And then they moved to Java. I think serverless is kind of the same thing. You use serverless to kick off your project, to start something as fast as you can. And one day, if you feel like a traditional infrastructure is better because of price or because of scalability, you go for that. So that's my approach for serverless.
Okay, I'll let you keep the mic. Give these guys a big round of applause. All right, thanks. Yeah, good job, man. All right, so let's talk a little bit about DevOps. So we alluded to this a little bit, that DevOps might be a good way for looking at some of these new technologies and how you approach it. And quite a lot of the folks in the room are doing Agile or DevOps. Actually, this is, before I joined Oracle, I was mostly doing Agile methodology, doing deployments and like infrastructure for our continuous builds. So this is an area which I've done a lot and quite recently. And I think the best way to describe this is to look at a comic. So I'm borrowing a nice comic from Gregor Zimonski, where he showed DevOps through the lens of a developer. So here's Dev and Ops. And as you can see, we have the wall of confusion, which is a very common DevOps paradigm. And then we have the poor ops guy gets blown up. Very unfortunate. So we can improve on this, right? So we take DevOps, we tear down that horrible wall of confusion, which is causing all this trouble. We work together with the ops people, so we build this culture. DevOps is all about culture, all about how we get processes, how we can extend Agile processes into the operations area. And yeah, well, it blows up on both of us. So slight improvement, right? And then Gregor has an interesting twist on this. He has his dev oops, which I think is cute. So basically, you work together with your DevOps guy, toss it over the wall, and make the customer pay. Now, I see you're laughing, but I'm going to show you some examples of how you actually do zero downtime deployments. And it looks very much like this. Okay, so this is the classic DevOps picture for kind of how the DevOps lifecycle works. So on the dev side, you're creating your software, packaging it up, verifying it. On the ops side, you're releasing and monitoring it in production. And then you want this nice integration where it's a continual loop and you're working together with the operations folks and you have kind of a nice synergy. And this is a simple way of like looking at how this flows through the system is a continuous delivery pipeline. So I picked a few random logos here. This, no endorsement of the said technologies, but they're all open source. And basically, you have some development process. So this is how you actually build your software, hopefully using some sort of agile methodology, test-driven development, distributed version control, all the usual modern niceties. And then you'll commit it into a build server, some sort of continuous integration server like Hudson, and then it'll do automatic code analysis and code formatting, and it'll run your automated tests and do all this magical fancy stuff which you have different plugins for. Then you kick it over and you do additional testing on it. This step would depend on your organization, how much of this you can automate and how much of it would be manual before you can release. And then finally have some hopefully automated deployments which would get it into production. And this is where you would do your cluster management, production monitoring, logging, scaling, hopefully using some modern framework like Docker, Kubernetes, something along those lines. So, looks fairly straightforward, right, for what you want to accomplish. But I think for DevOps, one of the key tenets here is to think of your infrastructure as code. So rather than treating the infrastructure as something which is managed by a separate team and they're doing a lot of manual processes, using something like Ansible, Chef, SaltStack, or Puppet, you can automate a lot of these things, actually check in scripts which will set up the infrastructure, provision Docker images, do all of the setup and configuration, and then do this in an automated fashion. I mentioned zero downtime deployment. This is kind of the bomb in if you actually get to this in a DevOps environment. So ideally what you'd like to have is you'd like to have an environment where you're deploying code and the customer never ever knows that you're deploying code to it. And there's a few different strategies for how you approach this, but basically it's a challenging situation to kind of rip the carpet out from underneath the end user and not have them be affected in some way. So a really simple way of doing it is just to have some feature flipping where you have options in your code and you turn on and off features. That is easy to conceptualize, but it doesn't really scale well because as you make changes, as you refactor code, as you do massive changes, it's hard to keep track of this. Dark launches are another tactic for approaching this. So you can take an entire feature and you can release it to the code base and not have it turned on. Not actually have it visible to end users, but you can have it active. So as an example, if you were implementing a new feature which required doing a bunch of search lookups, you could, as the user is coming to the page, you could execute queries which are going against your new search database engine. Make sure that it's working before you take the old one out. So actually you have it running in production, you're testing it, but then the end users aren't even aware that the feature's there. And then once you're sure that it works and it scales, then you can turn it on in a later release. Blue-green deployments are another strategy you can take, which is basically having a mirrored version of your infrastructure going live and then being able to roll back between the two as needed. This can be quite intensive in terms of hardware footprint for what you need to execute on it. So a more efficient version of that is doing a canary release where you, if you have a large pool of servers which are fielding requests, you just upgrade a few servers. So the guys at Netflix do this quite a bit. They'll upgrade only certain servers. If you're one of the unlucky people who gets a bug, then you'll get rolled back, right? So they'll eventually take that server offline and roll it back to the previous version if there's a bug in it. But once it's been out there for a while and they gradually increase the number of servers running it, then you know that it's stable just because you have a large user base. So really, most of these features, especially canary and blue-green deployments, depend on your end users getting the bomb. So not all of them at once, but you want a few people to experience the bug, report it, or you have some automated way of knowing that you hit an issue, and then you can roll back that change which caused an issue. Okay, and then we've been talking about DevOps. What about no ops? So you probably heard this concept tossed around at different events. So this is also trending around different conferences. And basically the idea with no ops is, so if we can do a great job of automating all this infrastructure, if we have cloud technologies like serverless that make it really easy for us to deploy code and not worry about how it gets run, why do we need an ops team at all? Realistically speaking, all you're doing is it's kind of putting back up the wall of confusion, and you're saying our developers only worry about developing, and they have instrumentation to say how it's going to be deployed, and then the ops side is entirely self-contained. Either it's a team which simply runs the infrastructure, sets it up, and provides guidance to developers, or it's completely outsourced, like in a cloud provider standpoint. So I guess the question is, how do you know as an organization that you're ready to take the leap from DevOps to no ops? And so I picked a few signs that I think you're ready for no ops. So the first one is your infrastructure 100% automated? I mean, this is kind of like the first step. If you can't get rid of the ops team, if you're doing manual steps, the developers, I would mess it up. I'm really bad at manual stuff. Does your code deploy itself? So it should. Does your application monitor itself? This is something a lot of developers don't think about, but in production, are you actually monitoring for different conditions, making sure that things are running well, and then have visibility into what's going on? And then can your application manage itself? So when something goes wrong, or when you need to manage things, can the application actually take care of the common things which are going to break, and can you upgrade and patch that in production to improve it over time? So if all four of these are true, you're probably a good candidate to start looking at more of a no-ops approach. But I think for most real organizations, at any given time, one of these is false. That you're not actually set up where you can effectively do no-ops. Okay, and then last topic we're going to talk about is machine learning and AI. So I think this is the most fun. This is basically a new research area, but it's actually not that new. It's been around since the 70s. Really, the research and interest on machine learning and AI has happened as a result of getting much better processing capabilities. So NVIDIA came out with some really great chips which are do teraflops of floating point processing, which is one of the things that are required to do this. And Google's been putting a huge investment as well with their TPUs. And the ability to have faster processing time on machine learning, and also applications for it like chatbots, and which requires speech recognition and other things which require analysis of large data sets, really makes machine learning an interesting field. So at a very simplistic level, what you're doing with machine learning is you take some inputs. So this could be from a data set, from a user. You have a bunch of hidden layers which are doing processing. So this is where the deep learning comes in. It's the number of hidden layers you have which are kind of running through the network algorithm. And then out of this network, you get an output which gives you some results. So the output could be like if you're trying to calculate, maybe predict fare prices for airlines, or if you're trying to calculate which word somebody said for a speech recognition algorithm, you'd have a different network set up for that purpose. You typically train these networks either through having a feedback-based training system where somebody kind of gives feedback on whether the answer coming out is right or not, or an automated system where it can tell based on the data set whether it's right or not, and then you can train it with an extremely large data set. The challenge historically with doing machine learning is that it's extremely both data and computation intensive. A lot of floating point calculations for the algorithms. A lot of cases it can take weeks to get an answer out of systems if you don't have sufficiently fast processing. And this is something which has changed recently with a lot of the focus on hardware for machine learning, is that you actually have fast systems to do a lot of this now. Some machine learning frameworks which are worth looking into. So probably the one you've heard the most about is TensorFlow. This came from the Google deep learning team. So it's an open source framework. You write your deep learning algorithms in Python. They also runs on their TPUs and their other hardware platforms. Cafe, Microsoft CNTK, MXNet, which is an Apache project, Torch, which is written in Lua, and DL4J, which is written in Java, are also all good machine learning frameworks to check out. So as a Java developer, DL4J from the Eclipse framework is probably a good place to start if you want to experiment with machine learning, but in the context of using your Java skill set. And I think it's an interesting area to learn and actually come up and try out some of these algorithms. And of course, you want to do this now to prepare for this coming singularity, which is inevitable. So the idea with the singularity, this is kind of a computer science concept, but at some point, the machines, the computers, the collective intelligence of all the machines in the world will exceed that of all of us. I think for us in the room here, it's definitely the case that the machines are smarter than us. I'll speak for myself. The machines are smarter than me. But eventually, they're going to get smarter than all of mankind put together. And so the question is, when does that occur? At what point does that occur? So, this is basically a graph showing basically the collective intelligence of machines versus humans. And there's supposed to be an inflection point, maybe around between 2040 and 2050, when the machines will actually be smarter than we are. So what conditions does it take for the singularity to occur? So one is, you need a large data pool to model and simulate things in general, but I mean, a good comparison is the amount of data in the world. And like for humans, a lot of our data is encoded in RNA and DNA, and in general, you can look across, different biological things. So for the human population, there's 7.2 billion humans, 6.2 billion nucleotides in each of us. So that gives you 1 × 10 to the 19th bytes of data. Each nucleotide has like 4 bits. In the digital world, as of 2014, we have 5 × 10 to the 21st bytes of data collectively stored. So there's already more digital data than there is in human DNA. And for the Earth as a whole, so you have 1.325 × 10 to the 37th amount of data stored in the biosphere. And that is also going to be overtaken at the current rate which data is expanding. So I think it's the estimate is about another 110 years, the digital world will have more data than our entire planet. The next condition for this to happen would be exponential rate of technology advancement. So I mentioned this a little bit earlier, but Google's been building specific units for processing machine learning algorithms called TPUs. They do arrays of 64 of these. So I think individually there are 180 teraflops, and then you get 64 of these, so you get 11.5 petaflops. NVIDIA also has a bunch of chips which for GPUs, which are quite fast at calculating machine learning. I think their chips do like 120 teraflops. And there's also work being done in quantum computing. So the first category is like mostly floating point operations, which speeds up machine learning. But if you actually want to simulate things like molecules or biological things, the most efficient way to do that is with a quantum computer. So IBM just came out with a 50 qubit quantum computer. I'm not going to go into a lot of detail on quantum computing, but it has like a few applications which it's quite good at, especially when you're trying to analyze things on a biological level. And the last step for this is full automation of technology production. So we're not quite there yet, right, where the machines can make the machines, but I like 3D printing quite a bit, and the RepRap project has gotten really close. So this is one of the latest 3D printers from the RepRap project. And basically it's a 3D printer which I think it's 73% printed itself. The only thing which they don't print is the hot end and some of the area which the filament goes through, and some of the electronics boards are not yet printable. But the entire structure of the printer, even the screws, everything snaps together, so you don't have any screws. That red thing is normally a big metal shaft, which you would normally have to get like an engineered metal shaft. So this can be entirely 3D printed, and it's a functional 3D printer. You can actually print real things on it, which is which is quite cool. So I saw this, and I'm going to have to try printing one of these later on my own and see if I can replicate a 3D printer at home. So what do you guys think? Is the singularity almost here? All right, who thinks we're going to hit the singularity before 2050? All right, a few folks. And who doesn't believe this stuff? Oh wow, we have a lot of doubters in the audience. All right, well, just to close, I'm going to show you that this has been proven. We already have evidence of the singularity.
In the 21st century, a weapon will be invented like no other. This weapon will be powerful, versatile, and indestructible. It can't be reasoned with. It can't be bargained with. It will feel no pity, no remorse, no pain, no fear. It will have only one purpose: to return to the present and prevent the future. This weapon will be called the Terminator.
Okay, so you guys all remember the Terminator movie, right? So pretty much, that's a prediction of the singularity coming in the future with Skynet and computers taking over the world. And that was done, was that in the 70s, 80s, early 80s? I'm really bad with my movie dating. So, I hope you guys enjoyed this presentation. You can find more information about what we're doing with developer outreach. My team built this site, developer.oracle.com. And you guys have a really great conference ahead of you today. So thank you very much for coming here to JNation, and thank you, Roberto, for having me here.
Okay, thank you, Steve, for that wonderful presentation. So we're done for now. So we're now going to move for the coffee break in the morning. So thank you so much for coming again, and have fun for the rest of the day.